Like you said, my name is Caleb Williams, and I'm going to talk to you today about web components. Getting started, I do want to mention that this entire talk is actually just a bunch of web components put together. All of the code is out there on GitHub. This is actually on GitHub pages right now. If you go to my Twitter or look at the ThunderPlains Twitter, they retweeted it. You can go out, find all the source code, and actually follow the pages. This is not perfect. I never intended it to be perfect. There are some things that I would have liked to have changed. But this is where the presentation ended up, so let's get started. So who am I? Well, if you Google my name, you'll get some interesting quotes. Particularly, many critics saw Caleb Williams as having a detrimental effect on society as a propaganda for anarchism. I have also been called, apparently, an affront not only to government, but also to justice, virtue, and religion, which is high praise. What are you going to do about it? Those quotes are actually about a book, so don't get too confused. I'm not the book. The book is not me. I'm actually a front-end developer for Capital One's One Design system. I support the financial services division. We primarily work with auto loans, but also some other tools and technologies. I have about 8 years of experience doing front-end development work. Right now, I work mostly with web components. I actually am leading an effort. Thank you. I'm actually leading an effort to transpose our design system to using web components so that they'd be available across multiple platforms and contexts. I'm Christian, father, husband, an OU alum, so if I say howdy y'all, just know that I'm saying it with a great deal of irony. A recreational sommelier, and probably not a Nigerian prince, although somebody who stole my email account a couple years ago would like you to think otherwise. So what are we going to talk about today? We're going to talk about web components. Has anybody here actually worked with web components? Okay, like 5 of you. That's awesome. That's more than I get most of the time. So, but before we do that, we're going to have a very abbreviated history lesson. It won't be nearly as in-depth or as eloquent or even good as Jory did this morning. But again, you work with what you've got going. So in the early 2000s, this idea of DHTML, or dynamic HTML, kind of began to crop up on the scene. The entire premise of it was to make our web interfaces dynamic so that we could change content on the page, deliver interactivity at a higher level than just HTML, or at the time, like CSS2 would allow us to do. And not have any requirements on an outside plugin like Java or Flash. Ajax, which is a term coined by one of my colleagues at Capital One, was how people did this. It was asynchronous JavaScript and XML. And what people did, like we've discussed several times throughout the day, send out requests to the server, get some data, put it onto the page. It was really a clunky process. But it worked, and for some things, it worked really well. The problem, though, is that browser implementations, like Jory mentioned, were not consistent. So sometime around 2006, a guy by the name of John Rasig created a library called jQuery. And jQuery attempted to resolve the conflicts that were inherent in each of the browsers and provide a consistent way to manipulate the DOM. It really separated JavaScript and HTML by providing simple utilities for things like event listeners and handlers. Before that, a lot of people would use on-click handlers in their HTML. Then it just turned into $element on-click. This is still widely used today, some 12 years later. Although the adoption of it has been trending downward with the advent of the modern front-end frameworks. But it really did revolutionize the way that user interfaces were built and consumed across browsers. Fast forward a little bit, we had there we go. Framework explosion in the early 2000s, right around 2010. A number of competitors emerged, things like Knockout, Backbone, AngularJS, and Ember. And all of these things attempted to solve a similar problem, which was giving scope to the DOM. And as much as I like that description, I actually had wanted to change it to, they all wanted to deliver on the promises of DHTML, that dynamic HTML paradigm that was brought forth by Jesse James Garrett in his original Ajax post. AngularJS, for better or worse, became the de facto standard for a while, although things like Backbone, Knockout, and Ember definitely had their market share. So AngularJS, I don't think I need to describe that too much to anybody. Created sometime also around 2010 by Miško Hevri. And it was originally model view controller, model view view model pattern, although today in Angular 4, 5, 6, and now 7, it's more of a component-driven architecture. One of the big things that this introduced or popularized was being able to define your own elements inside of your HTML. They would have attributes and events. You could keep your behavior and your HTML in sync very easily. It is widely adopted by enterprises and personal projects alike, and created a very robust ecosystem around it. So there were modules for anything that you might want to do or build. React came out a couple years later, built by Facebook engineers sometime around 2011 and open sourced in 2013. It's mostly a view engine, which means that it is concerned only with, or it bills itself as only being concerned with how the pages look and behave, not so much about the state behind them, which is a separation from what AngularJS was originally built as. Helped to popularize things like JSX and favors functional programming, which basically just means we don't mutate data. And it's primarily regarded as a library, not a framework, because it, again, is only that view layer. Vue created the next year, or was at least released the next year by Evan You. It was designed to be incrementally adoptable so that you could plug Vue components into any other framework or any other app slowly. You didn't have to adopt it all at once. Their source files combine HTML, CSS, and JS, and you can take some of those components and export them with a little bit of effort as web components. Since then, we've had obviously an explosion of frameworks, which has made this entire front-end development ecosystem remarkably complicated and a little bit frustrating to work in. All right, we have Inferno, Polymer, Preact, Angular, I think we're on 7 now, and 1,000 others that I've missed. I mean, don't throw anything at me, but I've created my own framework. Everybody and their cat is doing it these days. But the one thing that all of these are looking to resolve, or one of these things that they all have in common, is that they all want to solve for components. How do we do components well in a way that's reusable, modular, and scalable? Which brings us back to web components. Web components is actually a collection of technologies, including custom elements, the shadow DOM, HTML templates, and HTML imports. And I'll also add in there, in addition to custom elements, custom built-in elements or customized built-in elements, which there is a spec for that has been implemented. However, Apple is refusing to support it. So if you look at this stuff and decide you like it and you want the customized built-ins, go yell at Apple. These are browser standard tools that work with or without any framework. So in AngularJS, React, Vue, they can be plugged in and played and work nicely in any of those contexts. Originally, it was launched with a different API than it currently has now, which is V0, which has been called V0. So if you go out looking for documentation, you kind of have to pay attention to the differences between the V0 and V1 specs. It was originally an experiment by Google, kind of in relation to what was going on with Polymer. When it went actually to the standards committee, there was a lot of concerns from the other browser vendors as to some design decisions and API decisions that Google had made and they decided to basically rebuild the spec from the ground up. The first of these technologies that we're going to talk about, though, is the Shadow DOM. So who here has worked with Shadow DOM in some capacity or another? A couple. I think the best known instance of this is in Angular 2+'s view encapsulation. Angular 2 has an option where you can turn on native Shadow DOM to scope things like styles. So basically, Shadow DOM is a DOM tree. It's a DOM fragment that encapsulates a hidden DOM tree. That's a really geeky thing to say. So we'll show you what that means in just a second. So a Shadow DOM can be attached to many elements, not just custom elements, using the attach shadow method. So many DOM elements will have this attach shadow method. And then any element inside of the shadow root is not immediately selectable from the outside unless you have access to that shadow root. So if I were to run something like document query selector button, that if there's not another button in that document, if it's only in the shadow root, it won't be available. But it still retains things like its accessibility tree and its semantics. They give you access to special stylings for these things, so host and host context. So host will match the element itself. So if I have a div with an attached Shadow DOM, I pass in host as a styling in my style sheet. The host will style the parent element. And again, we'll get into what some of these are in just a second. So here's an example of how you might do that using JavaScript. Can everybody see the code okay? Cool. So basically, just walking through it real quick, we are taking creating a new div with the document create element and attaching a shadow root to it. So you'll see here we have this mode open. There are two modes a shadow root can take, open and closed. Open will append a new property to the element called shadow root, which is what we see down here. The closed method will return, or the closed mode will return the shadow root from this attached shadow function, and you have to save the reference yourself. So if you're wanting to completely close off the shadow tree, you can save that in a weak map or some other location. But anyway, this shadow root is just another element. It's like a document element. So you see here we're appending hello world. I'm inside a shadow root. Any styles added inside there are scoped. So they're not going to leak out, and styles generally don't leak into the shadow DOM. A couple notable exceptions, things like font sizes and colors and that sort of thing will leak in if it's not explicitly overridden inside of the shadow root. And selectors also won't do the same thing. So if you've ever run into the issue where you have an ID on an element and you wanted to reuse, on like an Angular component, and you wanted to reuse that component multiple times, that's technically invalid HTML because you can only have one ID of the same value in any given tree. If it's inside of a shadow root, however, that element will still be valid because it's closed off. So this is kind of what we did here is we actually created a special syntax to kind of illustrate what's going on. So you can kind of see where things are. So if we have, and actually let me do a hard refresh here. That's great. I added an example on here. If I can do this real quick. Of course, it's not going to work. Okay. Yeah, great. Let me do this. Sorry. Bear with me real quick. Slide 20. It's not going to work here either. Great. Never mind. So what we'll actually see here is that we have a div with a class of tomato, or style that defines a class tomato. Right? Pretty simple. Gives it a color of tomato. This paragraph here will have the color of tomato because it has the proper class. Inside of the shadow root, we have a style element that redefines tomato for the scope of the shadow root, and a paragraph inside. But this paragraph was not inheriting the class from above. It's inheriting the class from the shadow root. So this is all well and good, but sometimes you want to have kind of a mixed bag, right? Like AngularJS introduced the concept of content interpolation. So how do we, or content transclusion. So that's why they give us the slot element. The slot element will allow content from the light DOM to be transcluded into the shadow DOM. Any transcluded or any slotted content actually remains part of the light DOM. And actually, I'll have an illustration on that in a second. Yeah, so slotted content can be added to either a generic slot if it's not specified, or it introduces a new attribute onto that element called slot. And that can be added to a special slot, a named slot inside of the shadowed root. And this works just perfectly inside of any framework like AngularJS or React. So if you build out a modal component or something like that inside of a web component and plug it into React or Angular, the slotted content maintains all of Angular's bindings and stylings and that sort of thing. So this is kind of to illustrate this premise. So we see here we have a paragraph again with the class of tomato, and then our shadow root with a paragraph of tomato, and this time our paragraph is actually inside here. So what we're going to see is we have this slot element, and this paragraph will actually bleed into the slot. So what we can see here, I'm going to inspect this and blow this up a little bit. So we have this div here, and we have a paragraph of class tomato, and then a shadow block. Right now there's no shadow root attached to it. When I click this button, it will append a shadow root, and inside of it we see another element, class tomato, that is being affected by this style element. And then the slotted element, which will actually just have this paragraph inside of it, which is still part of the light DOM, so it still inherits the styling from above. So that's only one part of the custom element spec, or what people might call, or the web component spec, or what some people might call web components. The second part, and probably the most important part, is custom elements. So the custom elements API actually gives us a way to define new tags inside of the browser without anything like AngularJS or React. We can actually write our own custom logic and styles inside of a browser standard tag. So all custom elements are basically a tag name and a class that inherits from HTML element somewhere down its prototype chain. Any tag name that you provide is the tag name that you're just going to use inside of your element, but they must contain a dash, like my element, in order to be valid. Any custom element without a tag name will be rejected because the browser vendors have reserved these one-word elements for future use. It provides you with a couple APIs. First, since it's a class, it has a constructor. That's typically where things like shadow roots are attached if you want to do that. But they also have a connected callback that is fired when the element is attached to the DOM. A disconnected callback, which is basically the inverse. The adopted callback is what happens when an element is removed and then reappended somewhere else. And the attribute changed callback fires when a watched attribute changes on that element. So to do that, there's a static getter on each of these classes that you can define that you pass an array to with the names of the attributes that you want to watch. And as they change, this attribute changed callback function will fire. So here's an example of that, what that would look like. We actually have a class of myElement or myL extends HTML element. We're defining a static observed attributes array. And then we have this attribute changed callback. And what that basically does is it takes 3 parameters, a name, an old value, and a new value. And every time that this title attribute is changed, it will call this function. So here we're basically just finding the H1, and then if there's an H1, changing the content of the span to whatever we want, or that is on that attribute. Which leads us to the world's most useless demo. So here we'll actually see myL. So if we come back to this code, and we can see that the code is actually right here. So here we have a myL element and a form that really it's just an input. And on the input event on this element, it's actually going to update the title on this element, so the changes that are on the element are reflected right here, and then you'll see what actually happens. So if I say title web components, we get quick and easy bindings into our element because that element is set up to handle data from its attributes using that observed callback method. Yeah, and if we actually look at it, we can actually see that, where are we? myL, inspect, we're inside of it. If I change this manually to hell world, it'll automatically update. There are some best practices that have been discussed on these. Primarily, they align to the same best practices you might have with something like Angular or React. Each component must import and handle its own dependencies. Attributes bring data in, events push data out. So you dispatch an event. So we look at one of these elements down here. This is actually a custom element that when you click on the button, I'm not just looking for a click event. You can actually look at it. So it's a button, and when it emits an event, I'll show this in console. So we're going to emit a next or a navigation event with next as the details. And it's not doing, it's not doing that. Anyway, as it emits, this entire wrapper here is actually listening for that navigation event and progresses to the next slide. And one of the big gotchas out there is that the elements must be able to react well to the changes that are around it. There's actually a big bug in Angular that's bitten a lot of people on this, that Angular, when it's constructing a new element, will define or construct the element using createElement, then append it, and then apply any attributes. And if you're not watching for those changes, then your element won't work the way you expect. Some other gotchas, you can't add attributes inside of the constructor because you don't know when that constructor is going to be called. That's not been defined. And using that attribute changed callback, if you're also using getters and setters, will oftentimes result in stack errors trying to keep that data in sync. And you should also clean up after yourself at the end of these to prevent memory leaks. There are a couple tools that are built to make these a lot easier. Templiteral is the one that I wrote. That's the framework, quote unquote, that I wrote. I actually really enjoy it. That's what this was built using. But some others that are probably more popular and probably better include lit.html or lit.element, skit.js, stencil, and then there are other tools like Polymer and Angular elements, which are web components-esque or can export to web components well. So if you want to style a custom element, I think this is one of the big use cases of Shadow DOM and custom elements. The standard way to do it is actually to append a style tag to your Shadow DOM and just drop all of your styles in there. That's kind of a mixed bag for a lot of people. This is a big pain point because a lot of people tend to use SCSS or less or something like that. And it's difficult to actually put that right into a JavaScript file. However, there's currently a proposal to provide default styles to these elements, which you can pass in a JavaScript string, and it would style the element by default, which would reduce also that extra style node created every single time an element is initialized. There's also another proposal in the works right now to create constructible style sheets, where again you could say new CSS style sheet, pass in the data, which could also be imported from a CSS file using the JS import method. I also wrote a small library called Stylet to handle these. I'm not quite sure if it's a good idea, but it's an interesting one. So when and how should these elements be used? Personally, I think that custom elements can and should be used everywhere. So for every framework that I've worked in, I've worked at Capital One for nearly 3 years now, and I've worked in AngularJS, Angular, React, and Vue. And in every single one of those, I've had to write a new data grid or a new button element that does the things that we want it to do, like handle loading instances and that sort of thing. Earlier this week, actually, I wrote that same button element in custom elements and tried it out in Angular, React, Vue, and then without a framework at all, and it works just fine either way. I think that one of the big use cases for these is actually those atomic elements that you want in a design system that you want to be able to use across multiple frameworks and multiple platforms, that you want to have a shelf life that's longer than the framework that you're working in. And like Vue, these elements are incrementally adoptable. You can add 1 or 2 elements to your thing. You don't have to make your entire site custom elements because, again, they play really nice with any of the standard frameworks that are out there today. Shadow DOM basically should be used whenever you want to hide or encapsulate some sort of behavior or styles, or you need some kind of transclusion inside of your elements. So if you want to hide a content, if you want to hide content, if you want to, so like the video element is a great example of an element that has been built using the Shadow DOM into the browser. Under the hood, that is just a series of canvases and buttons that people didn't want you, or the browser vendors didn't want necessarily to be styled or any additional click listeners to be added because they didn't want any kind of hijacking of that content. So if you have a use case like that, it's a great use for it. Or if you just want to stop styles from leaking into and out of components. These days we have so many solutions for things like JSS and CS, or CSS and JS, where we import styles or write our CSS and JavaScript so that we can import it only in the right places. That's really not necessary anymore because the browsers can actually handle those kinds of operations themselves. But if you want the content to be generally selectable from the document, probably best not to use the Shadow DOM. The last major element of the custom element spec is the template element. For a template element, it's actually defined to have content that is not immediately available to the user. So I actually have a template element on this page. You can't see it because it's not being rendered, but this is the content of it. This is what it looks like right down here. So we have a template element with an ID, and inside of it, a paragraph with the class of subhead, and an empty span, and then our neat. So over here we can see this form. When submitted, it will actually clone this template and append it to the DOM below it. So conferences are neat. So basically what it's done is it's taken the value of this element, dropped it into this span, and then appended it to the DOM. And I can do this as many times as I want without constructing any new elements. So you are neat. Oklahoma are neat. I never said it was good at grammar. But basically, a template serves as a fragment that can be cloned and manipulated using the document import node method. This is really useful if you have a custom element or something that you want to provide a template for that does things like repeating. So ng repeat could be replicated using the template element, and then you would create an empty wrapper that just references a template and then does the transclusion on its own. And they're actually not particularly difficult to build. So when should the template be used? Basically, when you have content that you want to manipulate or use later, or if you define an element that you want some outside user to be able to control in some way. Again, similar to ng repeat. Currently, Apple actually has a proposal for template instantiation, which would do all of the transclusions and bindings for you. So similar to how AngularJS or Angular or anything else works, it would be using the same handlebar syntax. You'd have repeaters built in. You'd have some default directives and directives that you could define built into the browser, which would greatly reduce our need for these outside dependencies and these outside technologies, which I would argue is a good thing. We've gotten to the point in this industry where there are so many flavors and so many different ways to perform these actions that it's hard to keep track of them all. And every time that you want to re-implement a set of functionality in a new context, you have to build it from the ground up. If we target the browser instead of some framework that a third party has defined, then our code becomes immediately reusable and scales a lot better. And there's also considerably more performant. And for that matter, browser support is really good. Chrome and Safari have had support for the entire custom element spec for a good while now, aside from the HTML imports. HTML imports were a clever idea that was dropped because of some concerns about how module resolution would work and conflicts with ECMAScript modules. And Safari doesn't support autonomous built-in elements. Firefox actually released their version of Web Components earlier this month, or last month, so October 23rd, they released and launched custom element shadow DOM and template inside of their browser. And Edge finally, as of the 8th of October, announced that they would be, or that these tools were in active development. And for those of you that need to support things like Internet Explorer 11, or even back to 9, I believe, there's actually a polyfill, a relatively light polyfill out in the wild that backfills all of this functionality that far. So we don't have to wait until 2 years from now when somebody, or when Edge finally releases this, or when we finally drop support for IE11, finally. That's really all I have. Are there any questions?
Isn't there a website out there that has like other components that people built that you could inherit into your app?
So the question for anybody that didn't hear is there a website out there that has components that you could inherit or bring into your app that other people have built? There is, but most of those tend to be built with Polymer, which is not necessarily the same thing as custom elements or web components, but it has some extra dependencies. Anything else? So for like dependency management and that sort of thing? Well, so I would recommend using ES imports if you can, or just having a build step to do that. But as far as true dependency management in terms of like Angular or React, or not even React, like Angular, where you actually have DI, you'd have to spin that up yourself. But as far as like importing elements in, I would just use the basic ES imports or fetching scripts. Anything else? Cool. Well, I really appreciate your guys' time. And if you have any questions on this, feel free to hit me up on Twitter or, yeah, basically Twitter.